for questions at this point in time before we run through an example? Anybody, any questions? Okay, let's go for an example then. I think what we're gonna do is maybe Perry. I don't know that I want to share my whiteboard. Sorry, let's share Perry here. Okay, so I don't know, I'm gonna try this live. It might be bad, we'll see what happens. So let's try P as the next prime after, I don't know. All right, so P is 1, 2, 3, 4, 7. Everybody can see my Perry screen. Yes, you can see my Perry screen. Give me a thumbs up. Yes, we're happy, we're good. Yes, you can see me. Okay, cool. All right, let us do, I don't know, let's do a 6, 3 sharing screen. So that means I need a K value. I'm just randomly typing numbers here. That'll be a K. That doesn't work because that's too big. So let's try K with fewer values. There's gonna be my K. We've got A1 as that, A2, ooh, that's nowhere close to right. A2 can be that, A3, A4, I'm heading numbers there, and A5. Okay, so we've got values for K, and we've got values for A1, A2, A3, A4, A5. I need to generate some shares. So in order to do that, I am going to need to create a polynomial. I'm not sure how well I can do this in Perry, we'll see, but let's try it. I won't generate all my shares, but I'll generate some of them. So to generate my first share, I'm gonna need to do A5 times 1 to the 5th plus A4 times 1 to the 4th, A3 times 1 cubed, A2 times 1 squared, A1 times 1, and then plus K. That's the way that I generate my first share. Do we see where that polynomial is coming from? Right? Polynomial. And then I'm going to need to do that answer mod P. In this case, it doesn't need to be done mod P. I just have an answer of 4084. So my first share that I am going to generate is 1, 4084. Making sense on that first share? 1, 4084. Give me a thumbs up, nod at me. Yes, 1, 4084. Okay, all right. We can do one more. Let's do 2. If I can change these 1s to 2s a little bit easier instead of retyping the whole thing. So we can put in 2s instead of 1s. This one, I suspect that we might need to do a mod, but we'll try it. No, actually that one's okay too. So my second share that is going to go out is 2, 24402. Give me a thumbs up on that one. 2, 24402. We're good, we got it? Everybody's good? Okay, I want to run through this because there are some on your homework where you're going to have to generate a share. I won't generate the rest. We're going to do a different example for the Lagrange interpolation polynomials, but everybody's good here. We're good? We're happy? Okay, let's look at Lagrange interpolation polynomials. So for this one, you are going to need to know what a Lagrange interpolation polynomial is. I'm not going to be able to see all of you when I'm writing on the whiteboard, so you're going to have to do a virtual hand raise if you've got questions at this point in time. So Lagrange interpolation polynomials, here we go. Lagrange interpolation polynomials. Here's your definition of a Lagrange interpolation polynomial. L sub k of x is equal to, this looks terrible, but it's not so bad, I promise. The product, remember we use a sigma for addition and a capital pi for product, from j equals 1 to t. Remember, t is the number of people that we need to construct our secret. So j equals 1 to t, except j is not equal to k. So I'm going to leave this j equals k out here of x minus x sub j over x sub k minus x sub j, where all fractions are inverses mod p. And this is for k going from 1 to t. So we've got a Lagrange interpolation polynomial going here. L sub k of x is the product as j goes from 1 to t, but j is not equal to k, because otherwise we would get a 0 in the denominator. X minus x sub j over x sub k minus x sub j. That's a lot of symbols and that's not very helpful. Let me show you what I mean. So if we have, for example, let's say that t is equal to 3, I can create each of these. Lagrange polynomial, interpolation polynomial sub 1 is going to be j needs to equal 2 and 3 in this case. Do we see why? If t is equal to 3, then I'm going to need to have j equals 2 and j equals 3. See where that's coming from? J equals 2 and j equals 3. So this is going to be x minus x2 over x1 minus x2 times x minus x3 over x1 minus x3. So I need to have j equals 1, 2, 3, but not 1, because that's the subscript that I'm working with here. And then I plug some stuff in. My k stays the same, my j changes. Do L sub 2 of x and L sub 3 of x. Do both of those. And then we'll talk about how we're going to use these Lagrange interpolation polynomials to find k. All right, so do each of those. Okay, so for L sub 2, j needs to equal 1 and 3, right? So we've got x minus x1 over x2 minus x1 times x minus x3 over x2 minus x3. For L3, j needs to equal 1 and 2. So we've got x minus x1 over x3 minus x1, x minus x2 over x3 minus x2. Give me a thumbs up. You don't know how you're using these yet, but give me a thumbs up on yes, I can create a Lagrange interpolation polynomial. People are nodding at me. We've got thumbs up. Yes, good. Okay. All right. Let's talk about how we can use these to reconstruct a scheme. So we can then create this new polynomial, p of x, which is going to be the sum as I goes from 1 to t, f of x sub I times L sub I of x. We're going to create this polynomial, and once again, this is mod p. So we're going to create this polynomial, p of x. I goes from 1 to t, f of x sub I. This is the second half of the share. So second half of each share. And the x is a variable, mod p. And this is the same p of x that was used to create the shares. This is the same P of X that was used to create the shares. If this were a graduate level computer science or a graduate level cryptography class, I would prove that this is the same P of X that is used to create the shares. We are not proving that this is the same P of X that is used to create the shares. You can look up a proof if you want to. And then remember that K is equal to P of 0. So I can figure out what my K value is by plugging in 0 or by looking at the constant term. Okay, we absolutely need to do an example. So